Where's the 25 come from? All right. So, pretty challenging warm-up today. So far, I've seen a few people who got the right answer, a number of people on the right path. Let's see how well we did. Most of you should have gotten A right. That shouldn't have been too difficult. What do we get for the model? We'll start with Chris, John, and Dalton. Okay, what'd you put, John? Okay. Yeah, that's what we were looking for. H equals negative 16t squared plus 42t. Now, part B is where things got more challenging. Does the ball reach a height of 25 feet? So it's a yes or no question. Give me a thumbs up if you thought yes, it does. Okay, I got 1, 2, 3 people think yes, 4 people. Okay, give me a thumbs up if you think no, it did not. Okay, another 6 or 7 people. Good. So the correct answer is yes, it does. So now the question is when? When does it reach 25 feet? Start with Chris, Kadir, and then Davis. Chris. Okay, what do you think?
I think 1.71 seconds, because 25 feet is pretty tall, so we did it around 1 second.
Okay. Davis, what did you think?
I think the ball would reach the height of 25 feet at around 1.71 seconds.
Okay, so you seem to be in agreement on that. And the answer is that it actually reaches twice. At 0.9 seconds and at 1.7 seconds. Because the path of a ball, it makes an arc. And so it goes up, goes beyond 25 feet, and then it actually comes back down. And here is sort of an illustration of that. Here is the graph, bless you. Here is the graph. Now, you did not have to do the graph, but I want you to look at the graph. And you can actually see a number of ideas illustrated here. For example, you can see the maximum height of the ball right there. That's the highest point that the ball is going to reach. Here's 27. Let's see, 1, 2, 3, 4, 1, 2, 3. Looks like about 27.5 feet is the maximum height of the ball. Right? There has to be. The ball is going to hit a top point and then it's going to start coming back down. But you can see right here that it reaches 25 feet in two different places. And this vertical line right here, that's 1. So you can see that the point is just before the 1, and that's the 0.9. And here, this is the 2. This is the halfway mark, so that's about 1.7. So it reaches a height 25 feet twice. So now, could someone explain how we got that? Or at least start us off. Nathaniel?
At first, we all plugged the vertical motion model into the quadratic formula, which is equal to x equals negative 42 plus or minus the square root of 1,764 minus 4 times negative 16.
Okay. Okay, so hold on a second, though, because we skipped something. You were right. We are going to do that. But what did he skip over that was the critical step that a lot of my students missed? Kadir?
You had to subtract 25 on both sides. because.
You're right, we're going to do that, but we're not even ready for that because some of your classmates are saying, subtract what? 25. I don't see a 25 anywhere. So some of you advanced students, yeah, you're doing all the right things, but I'm now trying to explain to everybody. Go ahead, Edgar. So where does the 25 go? In place of H. This is the point that many of you misunderstood. Just because I phrased the question differently doesn't mean it's a different meaning. When I ask you, does the ball reach a height of 25 feet, what I'm asking is, will the end distance, that's what H is, the end distance, the end height, will the ending height ever be 25? And so now what Kadir was saying was, we can't solve this because you learned that you have to have a 0 on one side to solve. Which means we need to subtract 25 from both sides. Subtract 25 from both sides like this. That is how we get our 0 equals negative 16t squared plus 42t minus 25. So to get from here to here was a reading issue. That wasn't really math. And also, you had to know what the vertical motion was and what the different letters meant. I had a number of you who put the 25 in the wrong place. So if you're confused about what S is and what H is, I advise you to go back and relook up what each of the letters means. Now Nathaniel was correct. We are going to plug this into the quadratic formula. X equals negative 42 plus or minus the square root of, and when you simplify all of it, you end up with 1,764 minus 1,600. When you do that subtraction, it comes out to 164. All over negative 32. When you do the square root of 164, you get approximately 12.8. So you get x equals negative 42 plus or minus 12.8 over negative 32. And now that's where you get your two solutions. Negative 42 plus 12.8 over divided by negative 32. And negative 42 minus 12.8 divided by negative 32. Anyone have any comments or questions on how we did that? Or concerns? Nothing at all. No comments, questions. Everyone understands perfectly, and next time I give you a question just like this with different numbers, you will have flawless performance. Okay, very good. Put today's warm-up to the side. Today, we will be wrapping 2 lessons into one. And usually when I do this, I take 2 lessons that are very closely related, or 2 sections of the textbook where the publisher decided to do easy questions and then hard questions, or something like that. This is a little bit different. I'm actually taking 2 concepts that are related, but not really that closely related, and I'm teaching both of them on the same day. One of them is on the easier side, and you already should know most of it. One of them is very challenging. We're going to start out with the first concept, the idea of the discriminant. Using the discriminant. That's a difficult word. So you have to know the word, you have to know what it is. The discriminant. The discriminant is one expression from the quadratic formula. The discriminant is b squared minus 4ac. So, when I ask you what is the discriminant or where would I find a discriminant, That is it. B squared minus 4ac. And it is the part inside the radical symbol in the quadratic formula. The value of it can actually tell us a lot about the graph without even having to do the graph. You already know most of this. Here is what you can discover. If the value of b squared minus 4ac is positive, that means that the number inside here is a positive number, and you can take the square root of it, and you'll get two answers. If the discriminant is 0, that means that inside here is a 0, the square root of 0 is 0, and you will only get one solution. If it's negative, you learned during 10.4 that you cannot take the square root of a negative number. If it's negative, then there's no solution because that means you actually cannot take the square root of the negative number. So this is the idea of the discriminant. Any questions so far? Good, let's look at a few cases. First, you don't have to recopy the statement, but now you need the example. The equation 3x squared minus 7 equals 2x. First, we would need this in standard form. We'd need to subtract 2x from both sides, and so we'd end up with 3x squared minus 2x minus 7 equals 0. Now it's in standard form, and we can easily pick out A, B, and C. If we do the discriminant first, we will know exactly how many solutions we're supposed to get before we even do anything else. This is a huge benefit. Here's what it looks like. B squared minus 4 times A times C. You already know how to do this. You just demonstrated that in the last section. The value in this case comes out to 88. 88 is a positive number, which means when we finish solving this, when we finish it, we will end up with two solutions. Does anyone have any questions so far? Now here's a critical connection and an important question that I'm going to put to you. We don't have the graph of this, nor are you going to graph it. But what do we already know about the graph? Good. 1, 2, 3, 4, 5, 6, 7, 8 people know. Bump. Good. Good. I love the way you said that, Michaela. Very good. And she's right. They're called the zeros of the function, and it's going to cross the x-axis twice. Watch this. Hidden below here, I did produce the graph of this, and look at what we have. Without actually doing anything, we knew that there were going to be two solutions. 2 points on the graph where it was going to cross the x-axis. Does anyone have any questions on the graph or the connection between the discriminant and the graph? Not only that, since this is positive, what else do we know about the graph without even, if I hid this again, what else would we know about the graph if I hadn't even shown you? Sebastian? What does that mean? That's exactly it. It opens up. So not only do we know how many solutions there are, but just looking at it, we know that it's going to open up. Not only that, this number, does anyone remember what that number tells us? Let's see who remembers that detail. David?
How far up or down it is on the
Very good. Very good. Kadir, what were you going to say?
Translation.
Yeah, translation. Not only that, it's actually the point where it's going to cross the y-axis. It actually crosses the y-axis at -7. So we have an incredible amount of information about the picture without even drawing the picture. Very impressive, guys. Very, very impressive. Any comments, questions? All right, so let's take a look at what happens if the discriminant is 0. You don't have to recopy the statement. You already have that. But now copy down this example. 4x squared minus 12x plus 9 equals 0. It's already in standard form, so we can already pick out A, B, and C, and here's what it looks like when we get the value of the discriminant. B squared, 144, minus 4 times A times C, which is also 144, so we end up with 144 minus 144, and so we get the value of 0 for the discriminant. And that means that we will have one solution. So now I want you to think about a graph with one solution. What does that look like? John? Okay, so you got part of it. Danielle? I love the way you said that. The highest or lowest point is going to be on the x-axis. What is that highest or lowest point called? It has a name. Nathaniel? The origin is the center point of the coordinate grid. It's not called the origin. Diamara? Well, it's called the x-intercept, but for the parabola, it's called another name as well. Chris? Yeah, the vertex. The highest and lowest point is called the vertex. And so here is the graph of this, and look at what we have. It is touching the x-axis in one point, right there at 1.5. So there's only one solution to this. Yes?
But I thought the C, it wasn't +9?
Yeah.
But it's only on the x-axis, so wouldn't the C have to equal 0 then?
Nope. It's not. This value is not, you're getting confused between if there's a middle term or there's not a middle term. The middle term also impacts where it is. This is actually the y-intercept. Look at the graph again. 9, 9. The C value is the location where the graph crosses the y-axis. When there's no middle term, if we were to take this out, the vertex would be on the y-axis, which means the vertex and the y-intercept become one and the same. When there's a middle term, it's different. Okay? Very good. It's a good question. Other comments, questions? Chris? Yes. What's that? Hold on, I forgot something. 2x minus 3, sorry about that. So you're saying this number, if that number is negative, then it's not the perfect square trinomial. Is that what you're talking about? Which is this. This. Okay. Well, if it's positive, it will only have one solution also. But we'll talk more about that. Okay. But you're absolutely right. And so when you solve this, you get 2x minus 3 equals 0, and x equals 1.5. And that is another way to demonstrate the solution right here. So what Chris has made is a tremendous connection between what we've done in the past, factoring perfect square trinomials, and what we're doing right now. Excellent observation. Any other comments, questions? So let's take a look at what happens when the discriminant is negative. So here's the quadratic. 0 equals x squared minus 5x plus 5x plus 8. When we do the discriminant, we end up with negative 7. Which means if we were doing the quadratic formula, we would have to take the square root of negative 7, which you're not allowed to do. So when I reveal the graph, what's one major detail about the graph that will jump out at us based on that information right there? One, two, three, 4, 5, 6 people, 7 people. Edgar? Very good. So here is the graph, and you can see clearly that it never touches the x-axis. Does anyone have any questions on how to use the discriminant to help yourself know how many solutions there are going to be? Because that is it. That is all the work we are going to do for the discriminant. You will be on your own to practice. You have several questions on your homework assignment to practice that. If you have any issues or concerns with it, you can come to my care class any day that you need. Any questions? Good. So that's the easier work of the day. Now let's move to the more challenging work of comparing two of the models that we've used so far and a new model called exponential. The graphs, you just need to sketch, so it does not need to be nearly perfect at all. I have a computer that helps me make these perfect pictures. You do not. So now you need to be able to compare and understand major differences between a linear model, a quadratic model, and an exponential model. Linear, we spent the first half of the year studying. Quadratic, we've spent the last 2 to 3 months studying. Exponential, we've never studied. Now, there are many different variations of these graphs. Many, many, many different variations. Infinite variations. But these are just some basic examples. And today we're going to explore what these look like when you have a table of points, and how to tell whether a table of points will form a linear equation, a quadratic, or an exponential. Before we start that process, I want to point out some little strange details. There is a letter B used here, here, and here. This is kind of an uncomfortable thing. They all mean something different. the b in a linear equation does not mean the same thing as the b in a quadratic, and it doesn't mean the same thing as a b in an exponential. So that can be challenging for some people, because you would like to think that the b means the same thing, but it doesn't. The good news is that x and y mean the same thing. X and y always represents an ordered pair. X, y, x, y. Every point on the line is represented by an ordered pair, an x and a y. So that's nothing new. So the next page I'm going to put up is going to look totally different. It's going to be like, what? What are we looking at now? But once I explain what to do, you will have a good understanding of what's going on. You need to know these models because we're going to be using them in a little while. If you are missing anything from here, leave a little space on your paper and you'll fill it in afterwards, but I have to continue on. So, example 1, we're going to explore what a table of values can become. You do not have to copy the instructions, but you have to read the instructions carefully because you're going to see another set of instructions in a little while that is almost the same with one major difference. So example 1, tell whether the table of values represents a linear function, an exponential function, or a quadratic function. You need the table of values written down, so copy it down. It doesn't need to be perfect, but it needs to be accurate. And now I'm going to teach you how to do something that you've never done before. There is a way to analyze the table by looking at a relationship between the y values only. So we are going to take a couple of minutes to just explore the y values. The first test we're going to do, because that's what we're going to do, is we're going to do a couple of tests. The first test we're going to do is called calculating the first differences. The first differences. So, we're going to start with the 2, and we're going to go to the 5. What do we do to the 2 to get 5? Valerie? Add 3. So, everyone write plus 3. Now we're at the 5, and we're going to go to the 8. What do we do to the 5 to get 8? Alexandra? We add 3. Now we're at the 8, and we're going to go to the 11. What do we do to the 8 to get the 11? Matthew? Add 3. The first differences are all the same. If the first differences are all the same, that tells us one of these, linear, exponential, or quadratic. Does anyone know which one it is? Fung? It is linear. That is correct. So once we've finished the first differences, if they are all the same, we can stop. We now know that this is a linear function. And since we were asked to determine whether it was linear or exponential or quadratic, we can stop and say that it's linear. Any questions so far? All right, so now let's explore a second table. Here's the second one that I would like to explore. And let's see what we get from the first differences here. And this time I'm going to abbreviate the word difference by just putting DIFF. So again, we are going to explore the y values. And we're going to look at what trend is going on. So we're going to start at the 5, and we go to the 2. What do we have to do to the 5 to get 2? John? Very good. We're going to subtract 3. Everyone put minus 3. Now, we're at the 2. Go from the 2 to the 1. What do we have to do to get from 2 to 1? Dalton?
Subtract 1.
Subtract 1. Very good. So something is already different because in the first example, we got the same number every time. Now this time we're not getting the same number. So now, what do we do to get from the 1 to the 2? What do we have to do there? Kadir? We have to add 1. So we got all different numbers. So it's not linear, but now we have to figure out if it's quadratic or exponential. So now we have to do the second test. And the second test is called the second differences. So underneath the first differences, you're going to write second differences. And now we're going to actually explore this row. We're going to explore these numbers and what trends we can see here. So what do we do to go from -3 to -1? What do we do there, Valerie? You add 2, so everyone put a +2. What do we do to go from -1 to +2? I'm sorry, -1 to +1, I apologize. What do we do to make that change? Dave?
You add 2.
You add 2. And now there is something magical. We have gotten the same number again. So now the second differences are the same. Does anyone know what type of function this is going to be? Chris? Yeah, this is actually going to be quadratic. Any comments or questions on that? Go ahead, Chris.
If you see a y value here twice in a table, and you're given an x value, then it will always be a quadratic function.
You think so? Yeah, what value did you see show up twice? Yeah, so he observed this right here, and he already knew something was going on there. Very good observation. Any other comments, questions? Okay, so the last one we're going to explore. We're going to do the first test, the first differences. But I'll give you a second to copy the table. Don't waste your time making a perfect outlined table. Just X is going across, Y is going across. So the first difference is, what do we do to go from 0.25 to 0.5? What do we do there? Danielle? Add 0.25. What do we do to go from 0.5 to 1? John? Add 0.5. So we can already see it is not linear. What do we do to go from 1 to 2? I don't need a volunteer for that. We add 1. So we can see that the first differences are all different. Now let's check the second differences. So what is the change going from 0.25 to 0.5? Dalton? We're adding 0.25. And what about going from 0.5 to 1? Valerie? Add 0.5. So we didn't get the same thing again. So now we know it's not linear and it's not quadratic. So what is it? What is it going to be, Kadir?
Exponential.
It's going to be exponential, but maybe it's not. Maybe it's none of them. Now, if I said that it had to be one of them, then you would know it's exponential. But what if it's none of them? So we need to check to see if it's exponential, and now we need to do the third test. The third test is different than the other two. The third test is called the ratios. And now we're going to form a few ratios. And here's how it works. You take a y value and you put it over the y value that comes before it. So we're going to look at these two y values. We're going to put this one over this one. So we're going to put 0.5 over 0.25 and put that into simplest form. What does that come out to, Sebastian? Comes out to 2. Or 2 over 1. Now, let's look at these two values. 1 over 0.5. Put that in simplest form. What does that come out to? Only a couple of people know. Michaela? Yeah, it comes out to 2 again. Now take these two values. Put 2 over 1. That one's easy. That comes out to 2. And so the ratios all come out the same. They all come out to a value of 2. Once we get the ratios all the same, now we know that this is exponential. Any comments, questions, concerns on how we did that? This ratio is actually going to have great importance in a few minutes. So you have to know how to find that ratio no matter what. Any comments or questions? All right, let's see how you do on your own. Checkpoint number 1. Tell whether the ordered pairs represent a linear, exponential, or quadratic function. You got 3 minutes on the clock. Go. All right, we're going to answer this one by survey. Give me a thumbs up if you think it's linear. Okay, put your thumbs down and give me a thumbs up if you think it's quadratic. Okay, put your thumbs down, give me a thumbs up if you think it's exponential. So everybody thought it was linear, and it is linear. And just so you can see what I did, I took the ordered pairs and I formed a table from it, and then I did the first differences, and they all came out the same. It all comes out to +2. Does anyone have any questions on how this was done? So that was still the easy stuff of the day. Now we're going to take it to the next level. Example 2. So now, I said you didn't have to copy the instructions, but you need to read the instructions carefully and then copy down the first page. The one major difference is that it has a second sentence, or a second instruction. The second instruction is, then write the equation of the function. That can be challenging. If you know what to do and what to look for, it's not terribly difficult, and you actually know most of it. First, we have to determine what type of function it is. So, anyone have an idea of what type of function this one is? I got 1, 2, 3, 4, 5, 6, 7, 8 people think they know already. Nathaniel? You think it's linear? How do you know?
Because on -12 to -3, you got that for -8 to -4, you got that for continuous.
Okay, so the first differences, prove it. The first differences are all +4. +4, +4, +4, and +4. So we know it is linear. Now we have to write a model. And we are going to use the same model we used for the first half of the year. We are going to write an equation in this form. Y equals mx plus b. So ours is going to look like this. Y equals something x plus something. We have to find this piece of information and this one. Can anyone help us out? Ziamara, what do you see? The slope is +4. Are you sure? Okay. So she thinks that the slope is 4. We'll get back to that in a second. What about the other piece of information? How are we going to get that? Fun?
Putting the order pair, place it with y and then you multiply and try to find which number add up to y.
Okay, we could do that, you're right, but we would need the slope, and we're not sure about the slope. Ziomara thinks the slope is 4. We're going to come back to that in a second. So let's see. So you think we could plug in x and y and find it? Good. What do you think?
And you know, 0 is not happening with number x.
Well, that's not a vertex because this is not a parabola, but you are right. So everyone look right here. The information is in the data for us. The what? Guys, make sure you're paying attention. This is the critical piece. The y-intercept is going to be the y value when x is equal to 0. You learned that a long time ago. So this is going to be -4. So now, the slope. Ziomara says that the slope is +4. And she is correct, but I'm not sure if she knows why she's correct. She's correct because slope is rise over run. But see, we only have the rise. What's the run? Danielle? It's 1 because to go from here to here is 1, to go from here to here is 1, and go from here to here is 1. So Ziomara was right. I just wanted to make sure that she realizes it's not 4 because it's 4. It's 4 because it's 4 over 1, which is the distance here. And that's why it works. So the slope is 4. And so the equation of this function is y equals 4x minus 4. So everything we needed was in the table. What if it didn't come out to 1? What if it was like 2, and then 2, and then 2? Well, that's no big deal because this is the rise, this is the run. Just put the number over the other number and put it in simplest form, and you've got the slope. Okay? Comments, questions, concerns? So, I'm sorry, we didn't write down the first piece of information. It says to identify whether it's linear, exponential, or quadratic. We did say that it was linear, so we are writing that down. It is linear, and this is the equation that goes with it. So let's look at the next one. Excuse me, apologize. So there's only 4 possibilities. It could be linear, quadratic, exponential, or none of the above. Anyone have a gut feeling about this one? Davis, what did you think?
That is going to be a quadratic equation.
You think? Chris, what did you think? Fung? You think it's going to be quadratic? So let's prove it. So we do the first differences, and now this should be getting to be pretty easy for you. First difference is, what do we do going from there to there? Dalton?
2.25.
Subtract 2.25. Very good. What about there to there? What do we get? Or what do we have to do to go from there to there? Nathaniel?
Subtract 0.75.
Yeah, subtract 0.75. And what do we do from there to there? Keep going, Nathaniel. You're on a roll.
Add 0.75.
Add 0.75. Notice anything there? John, what do you notice? Very good. What about going from here to here? What do we have to do, Dalton?
Add 2.25.
Add 2.25. So look at the pattern that emerged. Subtract 2.25, add 2.25, subtract, add. So you will notice that when we do the second differences, so now, what do we have to do to go from negative 2.25 to negative 0.75? That's a little bit tougher. Good, I see people took out their calculators trying to figure it out. What'd you get, Sebastian? See? Sorry, I thought you had it already. Yeah, add 1.5. And what about going from here to here? From negative 0.75 to positive 0.75. Dalton? Add 1.5. And now we're seeing that the second differences all come out the same. And so now we know that this is quadratic. So we've answered the first part of the question. It's quadratic. Now we have to write a model for this, which is a little bit difficult. We are going to use the model y equals ax squared plus c. None of the examples that we're going to do today will have a bx. None of them. None of them that you have to know will have bx. So we just have to find a. We have to find a and we have to find c. Anyone find any of those pieces of information? Zimar? Yeah, it is. As Kadir was helping us see earlier, c is the y-intercept. And you can see the y-intercept, the vertex is 0, 0, which means it's crossing the y-axis at 0. So we already know that this is going to be y equals something x squared plus 0. We don't have to write plus 0, so we can just get rid of that. So now we just have to figure out this right here. Does anyone know how we can do that? Got one person who has an idea? Go ahead, Nathaniel. Well, it's quadratic, so it doesn't have slope. Okay, so I have a headache. Okay. That's understandable. So this goes back way, way back to the beginning of the year. Not the beginning of the year, the middle of the first semester, where you learned something that you can do to find a missing value like that. Look at what we have here, and look at what we have here. What can we do to find a? Yeah, plug in coordinates of x and y and solve for a. So here's what it will look like. Let's pick an easy one. I wouldn't use 0, 0 because it's not going to work out. Well, let's pick 2, 3. So y is going to be 3 equals a times, now x is 2, so do 2 squared. It's 4. Solve for a. What's a going to equal? Only 4 of my students can solve this simple one-step equation. Fun? Well, you don't need a decimal because it comes out to a perfect fraction, but yeah, it comes out to 0.75 or 3/4. And so, y equals 3/4 x squared is the equation of this function. Good, we're doing well. Clearly, at least one of you has a headache. That's fine. It is challenging work, and it's supposed to stretch your mind. So we're going to do one final one, and then you're going to try on your own. and then your brain will be able to take a breath. So, I'm also going to make your lives a little easier. So, if you just think about things as some of your classmates have demonstrated, your classmates have pointed out some interesting things that come about in the table. For example, look at the x values in this table. Look at this. There's a 0 here, and then there's a 1, and then a negative 1. And then there's a 2 and a negative 2. So what word have I used over and over again when you make a table like that? What did we do with the x values? Sebastian? They what? Yeah, they reflect. They mirror. If it's a quadratic, what should I notice about the y values? If it's quadratic, what should I notice about the y values? You know? They should be a mirror. That's right. That's something Chris pointed out earlier. That if this, I've kind of mirrored these should mirror each other, but they don't. Do they, right? That's an 8 and that's a 0.5. That's clearly not a mirror image. So this is clearly not quadratic. Nathaniel earlier was able to determine whether or not something was linear. How'd you do that so quickly before to figure out something was linear? I don't know. I guess that's what I get for calling on someone who has a headache. So what Nathaniel had said was he just quickly looked and he said, oh, well, that's subtracting 24, that's subtracting 6, that's not the same. Clearly it's not linear. So we know it's not linear, we know it's not quadratic. So now we have to test the last possibility. The last possibility was checking to see if it's exponential. And the test for exponential is calculating ratios. And this we do need to do. So you take a y value, the 8, and you put it over the one that comes before it. 8 over 32. Put that in simplest form, what does that come out to? That should be instant. You should have no trouble doing that. John? Yeah, you have it flip-flop, so what would it be? Very good, 1/4, excellent. So that comes out to 1/4. Let's do the next one. The 2 over the 8. So 2 over 8, what does that simplify to? Chris? 1/4. So now we're starting to see a trend. Let's see if it continues. 0.5 over 2. What does that come out to when you put it in simplest form? Daniela? Yeah, it comes out to 1/4. And when you do 0.125 over 0.5, what does that come out to when you put it in simplest form? Just a couple extra numbers to punch in. Davis? 1/4. So the ratios all come out the same. So what that tells us is that this is exponential. This is exponential. Now here's the part that you've never seen before. An exponential function looks like this. Y equals A times B to the x power. I told you earlier that B is different for all three models. And B, for an exponential, is the ratio. So we actually already know most of this. Take this ratio, and that goes in place of B. So we already know it's going to be Y equals something times 1/4 to the x power. So we have to find what goes here. We have to find the A. and we're going to use the same technique we just used in this second question over here, is we have everything except for the A. We have everything that we need except for the A. We have a table of values right here. Plug in the table of values in place of X and Y and solve for A, and then we can rewrite the equation. So pick one of the ordered pairs. I would pick this one right here because it's so simple, and plug it in for X and Y. I haven't left myself a lot of room, so I'm going to come all the way over here. So Y is 2 equals, A is what I'm looking for, times 1/4 to the 0 power. What is anything to the 0 power? You learned this a while ago. Anything to the 0 power equals what, Danielle? 1. So this really says 2 equals what number times 1? Could someone tell us what A is equal to? Michaela? 2. And so A is 2. And so our equation is Y equals 2 times 1/4 to the X power. Now that is not easy, nor do I expect you to be an expert after seeing one question. But you should have enough knowledge and enough understanding to be able to do one on your own. Okay? Michaela, yes.
I thought it was 2 before we did the equation because 0, 2, ordered pair.
I think that's a coincidence, but I will double check for you. Okay? So now you're going to try one on your own. Checkpoint number 2. Tell whether this table is linear, exponential, or quadratic, and then write the equation of the function. Wait a minute, something's not right. Hold on, I think this is the same one we just did, isn't it?
Yeah.
Yeah, I made a mistake.
Oh, it's quadratic.
Yeah, it's the same one. So everyone, so everybody stop. I made a mistake. I somehow put the same table, and that was a huge mistake on my part. So I apologize. So we won't be able to practice this, and we don't have time. We don't have time for classwork, so everyone will get a free point for this, which is, as you know, not really a good thing in the scheme of things because we need the practice. But you'll get a free point for that. So everyone draw a line across your paper. Your homework is on page 703. You're going to do 10 through 32 even. And then on page 710, you're going to do 6 through 20 even and number 24. Don't forget to write down the 24. That's not optional. That is a required question. And then you're going to have a test on chapter 10 on Friday.
So like